So we're talking individual pairs of shoes, right? So the outlier is a value outside the common range, something you see that's really far out there. Here I have 2, 2, 3, 7, 7, 7, 8, and 12. Do I see an outlier? Don't look at this. This is a different problem, okay? I'm going to move this. That's a different problem. Don't look at that. All right? So, 2, 2, 3, 7, 7, 7, 8, and 12. Well, let's say I had a value. One of my numbers in here was, let's say I also had a 57. Somebody owned 57 pair of shoes. Well, that is definitely far outside of what seems to be our range, right? Our range is one student, the minimum, has a pair of shoes. And one student has a maximum of 12 shoes. So the minimum is 2 and the maximum is 12, right? Pairs of shoes. This is your lower extreme. The minimum value is your lower extreme. Your higher value, your greatest value, is your upper extreme. But let's say I had a number 57. That would be my upper extreme. Well, that is very far away and very different than the rest of these numbers, right? So what about 12? Is 12 an outlier? Well, from your lowest number, 2, to the next number is 3 is only a difference of 1, right? So 2 is not an outlier. That's only 1 away from the others. What about 12? That's the next student has only 8. That's 4 pair. I don't know, maybe it's possible. Outliers are really up to your own discretion as of this lesson, okay? So maybe 12 is an outlier. You can decide, and as long as you can legitimize your answer, I think 12 is not an outlier because it's only 4 away, and you know, it's possible this person could have 2 jobs and require wearing 2 different pairs of shoes, so he's got extra shoes, right? Or this person could be a ballet dancer who has 5 pairs of ballet shoes. So it's not normal, but I mean, these things happen. So, you know, that number would be up to discretion, okay? But that's what an outlier is, a value outside the common range. Now later on we have a formula for determining specifically what is or is not an outlier, but not for this lesson. The range, the lowest value to the highest value. The range is from 2 to 12. So the range, the difference between your greatest value and your lowest value, the difference, that's subtraction. So 12 minus 2, the greatest minus the least. 12 minus 2 is 10. So my range is 10, okay? My range is 10 from 12 to 2. Data set, again, this is the data set right here. 2, 2, 3, 7, 7, 7, 8, 12, okay? So problem 1. Problem 1 is on page 712, and it says, finding measures of central tendency. The frequency table shows the number of job offers received by each student with 2 months of graduating with a mathematics degree from a small college. What are the mean, median, and mode for the job offers per student? I'm on the top of page 712, and they have this box right here, right? Here's the box right here. Job offers and students. 2 students did not have any job offers. 2 other students each had 1 job offer. 4 students, okay? 4 other students had 2 job offers. So I don't know, Mike, Mary, Sally, and Vlad each had 2 job offers. Doesn't mean from the same company, they just had 2 job offers. 5 other students, Bill, Bob, Barbara, Betty, and Oksana, they each had 3 job offers from some companies. They don't have to be the same company. And 2 other students, whoever, each had 4 different job offers from some companies. So the total number of job offers, two of them had 0, 2 had 1, 4 had 2, 5 had 3, 2 had 4. 2 had none, 2 had 1 job offer. 4 had 2 job offers, right? 4 had 2 job offers. 1, 2, 3, 4 had 2 job offers. 5 had 3 job offers. 1, 2, 3, 4, 5 students each had 3 job offers. And 2 students, 1, 2, had 4 job offers each. So the total number of job offers is 0 plus 0 plus 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 3, right? Plus. Add these together. Add all of these together. And the total job offers is 32. All of these added together is 32 job offers. There are 15 students. 2 students, 4 students, 8 students, 13 students, a total of 15 students. 2 plus 2 plus 4 plus 5 plus 2. 15 total students. So out of, did I add this right? Total job offers, 33, I'm sorry. 33? 1, 2, 4, 6, 8, 10, 13, 16, 19, 22, 25, 29, 33. Okay, 33. So 33 total job offers divided by how many students we have equals 2.2 job offers per student. Okay? That's the mean. So the mean is 2.2 job offers per student. The median, okay, the number right in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 2 is the median. Here we only have one number in the middle. Here we had 2 numbers, remember? 1, 2, 3, 4. 1, 2, 3, 4. Both of these guys. This is even amount of data, odd amount of data. Okay? 15 students, 8 students. That's even. 15 number of students, that's odd. 15's odd, right? So there's the middle, and there it is. Nothing to add. The mode is 3. We had 2 zeros, 2 1s, 4 2s, 5 3s, and 2 4s. So the mode, the most frequent, the 3s. So the mode is 3. If there were the same number of 3s as there was 2s, then the mode would be 3 and 2. Okay? But there's only one most frequent here. So that's it with that. We can find the range or an outlier. Is there an outlier here? Definitely not. Okay? Definitely not. 0s to 1s to 2s to 3s to 4s. There's no outlier. Range, well, the range is 4 minus 0. The greatest, the upper extreme, minus the lowest, the lower extreme. So 4 minus 0 is 4. So our range would be 4. Lowest value to highest value. The data set, well, this is our data set. Okay? Okay, next question is number 2, identifying an outlier. Multiple choice. Which is an outlier for this data set? They give the values of 56, 63, 79, 59, 98, 65, and 59. Okay, this is problem number 2. Okay, and I already explained outliers, range, and data set, right? Always, the first step is to put it in order, okay, from lowest to highest. You see 56, 65, 59, 98, 59. These are not in order, but now they are. 56, 59, 59, 65, 65, 73, and 98. Now it's in order. Now I can find everything. But the question here is, which is an outlier? So is there an outlier here? From here to here, 56 to 59, you have a difference of 3. From here to here, you have a difference of 25. 73 to 98 is 25. That's pretty far away, right? I mean, from 73 to 65 is 8. Okay, there's no difference from 65 to 65. There's a difference of 6 there. There's no difference between 59 and 59. 3, 0, 6, 0, 8. These are all okay, but this guy, 25, he's definitely, you know, this is too big of a difference. So this guy's definitely an outlier, 98, okay? So that's definitely the outlier, and they have multiple choice. So you chose C, right? But again, we can find the mean. We just add this data out and divide by 1, 2, 3, 4, 5, 6, 7. We find the median. Well, that's in the middle. That's this guy, 65. 1, 2, 3, 4. 1, 2, 3, 4. Same number. There's 3 here. There's 3 here, right? I've got 3 numbers here. 3 numbers here. This is my median. Okay? The mode. 56, 59, 59, 65, 65, 73, 68. Well, there's 2 59s and 2 65s. So the mode would be 59 and 65. Okay, we already said the outlier is 98. What about the range? The lowest value to the highest value. 98 minus 56 is 42. So the range would be 42. Okay? Data set, well, this is the data set. Now we're going to be moving on to stuff. And that was problem number 2. Now we're going to be moving on to example 3. We're going to be finding other stuff, like a quartile. Okay? Well, there's quartile 1, okay, and that's the lower quartile. And there's quartile 3, and that's the upper quartile. And these are medians, okay? They're medians. What is the median of the value below our median? What is this median? 56, 59, 59, odd number, it's this guy. So this would be Q1, okay? That would be first quartile. Then you've got 65, 73, 98. Well, it's odd, you take the middle. So this guy would be Q3, okay? Our upper quartile. Okay? So now we're learning. We've got other data now. We're learning, we got the mean, we got the median, we got the mode, we got outliers, we got range. We know our data set is our individuals in the data. Now let's go to problem number 3. Now, we're taking a bunch of data and we are wanting to compare the data. Okay? So, we're analyzing data and we've been talking about measures of tendency. So, measures of tendency. Make sure that's good. Okay, measures of tendency. All of these things we've talked about, the mean, the median, the mode, the outlier, the range, the lower extreme, which is your smallest value, the upper extreme, your highest value. And then I just introduced you to the quartiles, the lower median or lower quartile, and the upper median, the upper quartile, okay? Quartiles are like medians as well. So all of these things determine, or rather, all of these things are measures of tendency. How our data tends to show. Okay? Now, the book also talked about something called bimodal. On the top of page 712. A bimodal data set has 2 modes. If a data set has more than 2 modes, then the modes are probably not statistically useful. If I've got more than 2 modes, then the fact that I have more than 2 modes isn't anything significant, okay? If no value occurs more frequently than any other, then there is no mode. Well, we know that. The mode is what value do we see most, right? Are there a lot of 2s? Are there a lot of 7s? Are there a lot of, if we're looking at colors, a bunch of colors, is the majority of the colors red? Then the mode would be red. But if we've got 100 pieces of data and I've got 5 8s, I've got 5 20s, I've got 5 30s, I've got 6 35s, I've got 6 40s, I've got 7 28s, I've got 8, that means I've got a lot of modes, right? That means the fact that I've got a lot of the numbers that are the same doesn't really mean anything. It's just data. But if I've got numbers that are just like 1, 2, 3, 4, and then 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, and then 6, 7, 8. Well, obviously, the fact that we've got many 5s, that means something, right? Okay, so comparing data sets. Problem number 3. Don't look at box and whisker plot. That is how we display this type of data. Okay? I think you should have seen that before. But it doesn't matter. We'll get to that in a moment. We're going to take all the data we've learned and we're going to compare it to 2 different things, right? So, the problem number 3. I'll read the top above the problem. It says the range of a set of data. Well, I already talked about the range. You know what the range is, right? The difference between the highest value and the lowest value. That's the range. Is the difference between the greatest and least values. If you order data from least value to greatest value, again, step 1 is always order your data from least to greatest. The median divides the data in 2 parts. The median, right, divides it into 2 parts. The median of each part divides data further. In other words, we have this data. The median divides it in half. And then we can divide this half and we can divide this half, right? Here's the lower half. I can divide it that way. Now I've got